Resonance occurs if there is a double bond that can equally be on either side or somewhere else in the molecule. So if they're pretty much equal compounds, pretty much one's just flipped or rotated or whatever. And so when that happens, what's actually going on is the electrons are actually evenly spread out throughout the molecule and they're delocalized. So what you do is you'll just draw a dotted dash and get rid of the you don't draw in the non-bonding pairs, because what's going on is actually a lot more complicated and it's very, very difficult to draw, which we can attempt to do maybe at the end once we've done hybridization. And so what's actually occurring is a pi bond. So they're all in the pi orbitals and they're all, you can see they're not on the internuclear axis here, the bond axis. They're actually floating above and below, and they just spread out and share amongst the whole lot here. And so that's a pi bond. So we will go into sigma and pi bonds in a separate video in a lot more detail, but that's just to let you know what's going on. They're floating above and below and resonating, and so that they're all at the equal sort of distance. So the experimental evidence shows that. When we do benzene in the next video, we'll go into a lot more detail about the experimental evidence of it, but the lengths are exactly the same, not a shorter one here and two longer ones, which you'd expect if this was the true molecule. Okay, so that's called a resonance hybrid. Once again, I didn't draw that's how you are to draw it. So everything but the non-bonding pairs and back up to nitrate. You can see this just rotates. So the double bond can be in more than one place, and that is the definition and the deciding factor to tell it's a resonating structure. And there it's drawn for you right there.